Everyone. I think we're going to get started with Rinka's presentation first, like I mentioned before. Thank you so much for joining in and keeping patience. Rinka, you can go ahead and then we'll take the Q&A right after you're done. So everyone, like I said before, please keep dropping your questions in the Q&A box.
Yeah. First of all, my apologies. I'm starting late on this session. I was a bit stuck somewhere else. So apologies for that. What I will do in the next maybe 20 minutes to half an hour is to kind of run through a few things like, a little bit, of course, who we are and what we do, but some of my learnings around product development and, how some of the high quality R&D innovations are done. If we have the time, I'd like to spend a little bit of time in terms of the trends and innovation areas I see, and all of this in terms of how do we link this up to the whole area of plant-based foods and, the smart protein area. Yeah, so that's a little bit about what I'm going to be covering today. So a little bit about Thinking Folks, a company that I founded about 9 years ago. What we do for the industry is essentially do a lot of end-to-end R&D. We do product development, packaging, nutrition, manufacturing, and so on. And we work with some of the large companies as well as a lot of startups that we've worked with. Yeah. And I will, along the course of this presentation, talk a little bit about some of the stuff that we've done in the plant-based foods area. Yeah. We work across 3 key verticals. One is around completely new product development. So it's, based on a concept or an idea that a lot of times customers come to us with, develop products, pack claims, and that's very important aspect of product development is how do you communicate the benefit of the product that you've done. And then, of course, manufacturing and food safety and quality and so on. And then, of course, we do a lot of technical services, whether it's cost savings, sensory and consumer panel testing, nutrition and regulatory, like I said, is a core of what we do, and packaging and so on. The other area that we've been looking at, and this is an area, where we're looking at even plant-based foods and stuff like that, is in terms of saying, how do we collaborate with partners? And I can see Dr. Gurmeet Singh here, and we've been working on a lot of collaborative areas. How do we collaborate with the right kind of partners to develop new solutions for our clients? And that's something that we do. And we're looking at some interesting spaces like aging, for example, is an interesting space where we've got both plant-based as well as, dairy-based solutions, and then looking at accreditation and stuff like that. So this is a little bit about our team, and super experience. It's got about 30 years of experience in the industry. Typically, each one of us has, and it's a collection of food technologists, chefs, nutritionists, packaging, and, regulatory manufacturing, and so on. Yeah. These are some of our clients, and I will come to it in terms of plant-based, some of them that we have worked with. Yeah. Through some of the case studies, I want to maybe just touch upon some of the stuff that we see as trends. And so one of the trends that we've seen is a lot of companies come to us, a lot of startups, for example, come to us with single ingredient products, right? Let's say, for example, it is chickpea protein, or it is seaweed, or an algal protein, and things like that. How do you, from a product development perspective, do the right kind of blends to make sure that it's a consumer palatable, desirable product? And that's something that we did for seaweed. We are seeing a lot of trends in the space of ancient grains, ancient herbs and botanicals and things like that. Gluten-free, et cetera, is still very new in India, but that's another space we're seeing picking up. We've done a fair bit of stuff around plant-based foods, whether it's extruded snacks, egg replacement, and therefore having an omelette kind of a replacement, or a plant-based bar, things like that. Yeah. In the application space, and this is something maybe I'll spend a little time on, and this is where we are seeing some of the interesting ingredient companies like Proeon. I'm sure a lot of you use them for, let's say, chickpea protein, mung bean protein, stuff like that. Or if you're talking about mycelial proteins, algal proteins from seaweed, fruit extracts that we've actually been able to valorize from the waste that fruit processing industry generates, and create certain active ingredients that go into plant-based applications. So whether it's acting as a meat alternative, and again, we've done a lot of collaborative work where we've actually done trials at TDU and things like that, where we've created different meat alternative options for some of these ingredient companies, whether it's in a bar space, breads and snacking is a very big space, and beverages as well. So for some of these ingredient companies, we've actually created applications for some of these plant-based ingredients And they are now today showcasing it to a larger audience of the industry to say, how can this behave in a bread? How does this behave in a cookie or in a bar or meat alternative and things like that? Yeah. And this is how we end up creating technology playbooks. So basically understand what is your feedstock, what's the kind of material that you have, how do you then blend them from a product development perspective, and then, create different technologies, prototype them quickly, and then, come up with the whole manufacturing scaling up process and stuff like that. Yeah, that's a little bit about us. I will spend maybe a couple more minutes in terms of what is the typical kind of innovation process and formulation process design that we use. And we've some of us who've been spending so many years in the industry have learned to do this in a certain way. I would say one of the things that one needs to always look at in any kind of an innovation process is, and today of course you have things like design thinking, which is nothing but really ensuring that you're empathizing with your consumer, you understand what the consumer needs are, maybe market needs are, and then based on that, you're able to design products that, meet some of those needs. Then you test them, you validate, and this is a process that can be sort of, going a little back and forth. If we run it in a modular sprint-wise kind of a fashion, so you run it very linear, very, sort of in short sprint kind of a fashion, and then you see what's working and you scale those things up. Yeah. Just a quick thing in terms of some of the successful innovations. What are the key metrics, right? So how much of revenue do you get from your innovation? That's an important metrics. How much of gross margin are you able to get from your, products? How much of repeat purchase? And this is very important because a consumer, and we all get very excited when people come and buy our products for the first time. And so we're showing a lot of, initial sales. How many people are going to come back again and again? And how many people are going to make it a habit to have your product? That is a very important metric for a good, successful innovation, right? The other things in terms of speed to market, profitability, and all of that are other important criteria. And sometimes innovations are also measured by, do they have the potential to create IP, things like that. Yeah. My personal learnings in terms of what I have seen as successful innovations, and this is something that a boss of mine told me many, many years ago when I just started my career, saying, you've created a good product when you feel the need to go and buy it. You sort of say, yeah, this is a great product. I love to have it. And I've had in my journey a couple of products, which I think that even today, I as a consumer go and buy those kind of products because I like them, right? The other important thing, and it's very important for product developers to think, did I either solve a problem or do I create a need? So for example, when packaged yogurts came into India, did it solve a problem? Yes, it did, because people had to put, dahi, you keep it for X number of hours and things like that. So when you're doing plant-based food innovation also, it's very important. And this is a conversation I've had many times with some of the people in this space saying, what is the consumer problem that you're trying to solve, right? Is today the consumer problem to say, hey, I'm looking for an alternative to egg or meat, etc., or is it that an Indian consumer who may or may not be looking for it? Are they looking for high quality nutrition coming from some of the plant-based foods? So those are the kind of questions to ask and solve. The other thing is, to create a great product, you need to have moorishness of the product. When I mean by moorishness, it's, would I want to have a lot more of this product again and again, right? And that's when you've created a great product. Understanding your guardrails, which means what kind of nutrition guardrails do I have? What kind of, sensory and all of those guardrails do I have, right? So these are some of the important things. And one very important thing, guys, is very important, think out of the box. Yeah, we are very good at sometimes thinking very linearly, right? We need to be able to look at parallel solutions in different industries, and can we bring them back into the industry that you are working in, and to sort of create solutions from there. Yeah. The other thing that's super important is to be able to communicate the product benefit that you've created. Yeah, and I'll talk about that in the context of some of the plant-based foods that we've done. Yeah, this is a typical process that we use, and I'm not going to spend too much time on this. And if anybody has questions later, happy to take this on. But you need to go through a certain set of activities that you do at each of these stages. They don't have to be exceptionally long, but the same thing, you can also run a lot of activities in parallel, right? Right. Now, I mean, these are all details which you can look at, saying, when customers come to me, and sometimes I've had lots of startups come to me saying, I've got this brilliant idea and this is what I want to do. But I always ask them for giving me a design brief, right? I always ask them these questions, and this is something very important for every product developer to know. Who's the consumer that you're trying to target, right? What do they consume today? What are their habits of, towards any particular food category, or the way they consume their products? Maybe what time of the day do they have it, depending on what the product is, right? Who's your competition? Why would somebody want to buy you, right? What is the benefit? So we help our clients first really think through this really well. And then based on that is when you come to what are my product attributes, etc. And then you come to a very clear design brief for for product development. Yeah. And the same thing goes with packaging. Sometimes I have clients saying, what, for me, product is the most important thing. I'll go with packaging, whatever is available in the market. And some people will come to me saying, I want something which is very differentiated. Let's say, for example, a Kinder Joy, right? They've used this whole gamification in some ways. They've gamified that packaging thing. Now, that can be a very disruptive, innovative way of thinking as well, right? So those are important things that you need to think through. And then, of course, to do quick prototyping. It is good to understand some bit of consumer insights. And today, a lot of people do social listening. They do look through what are people talking about a particular category in, let's say, social media, things like that. A lot of secondary research one should do. Identify some of the new products that are happening in, in different maybe platforms, Amazon, etc. And say, basis that, like, what would I differentiate my product with, right? And then quickly prototype, test them, pretty rapidly and quickly, right? Very important to create a very clear design of experiments. I always tell this to my team as well, that your design of experiments have to be very, very clear. Why would I be using certain ingredients? What's the rationale behind me using certain ingredients? What kind of sensory attributes do I want? And I'll come to that when I'm talking a little bit about how you do good product development in terms of using sensory and stuff like that. Because at the end of the day, in India, taste is everything, right? You can make a great plant-based food or any other food, which may be very high on nutrition and everything. But if it doesn't taste good, nobody's buying it, right? So that is an extremely important thing to keep in mind. Right. And of course, applying all your food science principles, whether it's a high moisture, low moisture food, you're talking of high acid, low acid, all of those things. This is extremely important for a product design, because that is what gives you shelf life. That is what gives you safety, and those are important things to keep in mind for a good product design. Yeah. And these are all the you can, let's say if I'm looking at a dry product, right? And I need to typically, I would say, okay, if that's my product that I want to do, let's say it's a soup, I would definitely want to have moisture less than 5%, water activity less than this. So therefore, the manufacturing facility where I produce it, it should not have high humidity, for example. So there are certain good category GMPs that are for each of these different kinds of products that you're trying to create. Now, whether that's plant-based or not, this is fundamental to everything that you do in terms of product design. Yeah. This, I want to spend a little time on this. And when I'm looking at some of the plant-based products that we did, for example, let's say high protein puffs and all, this is almost 50% protein in an extruded snack. Yes, it's a great story to tell, it's a lot of good fiber, all of that stuff, but you have to create some really, really good flavor delivery. People have to come back to you, not because it is just high protein and stuff. They have to come back to you because they really love the taste of the product. That is important. So, whether you're looking at, different, so one of our clients, for example, and he's into popcorn, and he created a beautiful truffle flavor, right? And it was a very nice thing of a little bit of butter, a little bit of, like, it's almost like a caramel kind of a flavor, but in a popcorn, which was very interesting and nice kind of a flavor profile. So I'd like to keep coming back to it. Right. Similarly, when we did the seaweed bites, and seaweeds have an extremely strong algal fishy note, right? How do you pair it with the right kind of ingredients? So, for example, we use things like dates, nuts, seeds. There were certain syrups and stuff like that, which gave it a great flavor pairing and a food pairing to give it a nice texture, nice flavor profile and things like that. Today, of course, the flavor industry has a lot of maskers. There's bitterness maskers, soy protein masker. There are a whole bunch of maskers that are available. One can use some of those kind of ingredients to amplify or mask some of the off flavors and things like that, right? And like I said, it's very important to be clear about how you're communicating the benefits of your product. So the claims around your product are extremely important, right? Today, consumers are also looking for very basic ingredients to be there. So for this particular panlet kind of a product, initially when we started off, we didn't want to use very large amounts of, this protein concentrate and isolates and things like that. So we took things like, moong dal, gram dal, right? So some of these soy protein, etc. With the right kind of combination of spices, condiments, etc., you've got a nice tasting product, right? So these are things which, are very important, and stuff like, let's say, a starch or a gum or all of those are functional ingredients. They play a certain role, and that's something that you might need to add. Rest of it is, of course, documenting and having everything specified when you scale up a product. So, your raw material to packaging material, process, finished goods, specifications, things like that. This is very important for making sure you have consistent product quality, which can be scaled. So we have a lot of startups who come and they do the first couple of batches and we are there with them and so on. But what we do is to make sure that they have a playbook or a technology transfer document, which has everything that tomorrow that becomes my Bible. And that is something that I should be able to keep on repeating the same batch, right? So this is how a typical technology transfer document must have its formulations process, specifications, all the shelf life testing and all of that stuff. And the other thing is, if you're making claims, ensure you've got claim substantiation. You've got some kind of a monograph to tell you that these are the kind of, reason why I can make these claims. Yeah. So let me just run through some key things that I see, right? And we are, as an industry, we see. One of the things is, of course, we all know that health and wellness is one big area. People are being very conscious of what they're consuming, whether it's clean label, whether it is, where this is coming from, etc. All of that, right? Superfoods, adaptogens, those kind of ingredients are coming quite a bit into whether it's plant-based or not. I mean, those kind of additional benefit areas are something that people are looking at. The other space that we have seen a lot of things that we see is whether it's in a beverage or in a snack or whatever, the whole thing about familiarity and nostalgia. So people using Indian flavors or fusion flavors, but having that, that nostalgic taste, or like one of our clients actually used, those really old time, we used to get these parlay kismis, they were literally like, I don't know, 50 paisa kind of candies, right? Now, can you get that kind of a flavor profile but into your cookie? Does it make you nostalgic? So that's a very interesting space. The other area that we're seeing is a lot of snackification of food, which means people are consuming less large meals, but more of the smaller short meals. Yeah. And then, of course, and this during COVID, I mean, there was obviously a lot of eating at home. So there's a home delivery and things like that. So that's another interesting area that, you all should look at. And of course, new cuisines and fusions and stuff like that. Couple of things, like I said, health and wellness, conscious consumption. One big area is trust. And I think this was also partly because of COVID, etc. People wanted to be clear that your product is safe, the food is safe. So there's a lot of demand for transparency. How do you label your product? What kind of accreditations you possibly have in your product? Those are differentiators also for your products versus some of the large, big brands. Yeah. Like I said earlier also, but at the end of the day, you can deliver a great, healthy, nutritious, whatever product. But the taste of the product has to, is what kind of defines, how well a consumer is going to be accepting a product or no. Right. Of course, some of these things like protein and fiber, and I'm sure all of you have seen this, there's a lot of uptake of that. I would say from a plant-based nutrition, plant-based foods perspective, and I've said this earlier as well, if you're able to deliver pretty high quality nutrition through the quality of protein that you're putting in, fiber, etc., whether it's a combination of soluble, insoluble, all of that, that has a pretty big traction and reason why I should buy, a product which is plant-based, but it has all of these things, which is, good quality nutrition. And I think that's something that we don't talk yet enough of. We talk a lot about quantity of nutrition, but we don't talk quality. I think that may be an interesting area for you all to think about. Yeah. And like I spoke about trust and transparency. And then, of course, a lot of us today are doing things over online virtual meetings, things like that. So whole area of snackification has become big. And therefore, even in plant-based foods, I do see as a big opportunity for snacking. Yeah. Using adaptogens and mood-boosting ingredients and things like that, this we are seeing globally is a big trend. Keto is still small in India, but I guess weight loss or weight management, diabetes, these are the areas where there is a lot of traction. And if we can come up with more plant-based solutions which handle those kind of problems, that is what we need to, could be a big opportunity. Yeah. Yeah, and this is, of course, I mean, plant-based is, while it's still emerging, I think if we are able to create good benefit areas and reason why I should have your product, because it, either it helps me lose weight or it's giving me a lot of dietary fiber and therefore it's good for my gut. It has to communicate the benefit to me very, very clearly. Then I'm more likely to buy your product, right? So yeah, and of course you've seen a lot around clean label and, cleaner set of ingredients and things like that. Yeah. If the product is a lot about nutrition and healthy, some specific ingredients, today consumers are looking for scientific substantiation and efficacy. Not everybody can do a clinical trial for sure, but just having a lot of like literature search, scientific search to just back your claims are always a good thing to have. Yeah. And of course, like I said, about taste and so on is super important. This is something that we're seeing across the globe, right? Really, like using a lot of traditional grains, so ancient grains, ancient herbs. Those are things that are really picking on, and whether it's plant-based or any other food category, this is another area that we see a lot of traction. Yeah. This is an area we're more recently working on, is upcycling of fruit. So a lot of people who are using waste fruit, low value products, how can you upcycle it, right? So we did this with fruit. We've seen somebody who's used waste, for example, from brewery, which is high in fiber, for example. Can I use that and valorize that and create a new product out of it? Now, those could be very interesting areas for us to also say, how do we take some of the plant waste that you take, and can you either you take substandard or lower grade stuff and you upcycle them, or you use some of the plant waste and valorize them. So I think those are, again, interesting areas for plant-based foods. So I'll stop here, and happy to take on any questions and any comments.
Yeah, I think we have a couple of questions in the Q&A box. So I'll just quickly read you through some of them, and then you can respond. So the first question is, what are some innovative approaches to smart protein product development that you have seen showing promising results in recent R&D?
Right. So I think, like I said, some of the approaches that we are seeing in the smart protein segment is, and one of the challenges also that protein, sort of smart protein area has, is in terms of managing taste delivery, right? So it's extremely important. And today there are many different flavor companies working with, multiple different solutions, right? So for example, we've used a lot of ingredients like yeast. Yeah, we have used ingredients. Of course, you've got your bitterness masker flavors, and you've got your, certain other sweetness enhancers and things like that. But can I look at certain other flavor sources like yeast extracts? Can I look at, if I want to have a lower sodium, I know that if I increase the sourness of my product, I can get better salt perception, for example. If I want to mask the flavor profile of certain kind of proteins, and we've done this with algal proteins and stuff, they were not easy to mask at all, right? Can I pair them with interesting ingredients which some of them mask, some of them amplify. And I think that is where smart product development also comes into play. That's one. The second approach is in smart protein. And I again go back to the idea of saying that you need to be able to say, what's the nutritional delivery that I'm giving? And it's not about the quantity of protein that, something is 20 grams and 2 grams and 10 grams and so on. For me, it's all a lot about what is the quality of protein you're giving, right? Some people talk about PDCAS, which is the protein digestibility scores, things like that. So those are important things also to consider in communicating and designing your products, right? I don't know if that answers your question.
I think that does. Thank you so much. The next question is that, how do you guys help a startup that has a clear product in their mind, has extensive knowledge on the ingredients, but is confused about how to put those in the right place? And may I also know how much you charge for new product development and the duration it takes?
So yeah, I'm please happy to, just connect offline with me, just drop me an email and I'll connect you with the team. But like I said, what we do, and we do help a lot of our startups. Like I said, a lot of startups come to us with, bright ideas, and most of our disruptions, by the way, happen with startups. And I'm super proud of that. I think that's something that's really good. But we have to help our startups articulate why you want to do this, right? What is the right you are going to have to win? Let's say, for example, I'm just making this up, but let's say, you want to do something in the space of an oat milk or something like that, right? And you may have a larger brand who's already there, right? The question would be, how are you going to differentiate? What are you going to, look at in terms of differentiation? Is it going to be packaging? Is it going to be some new active ingredients that you're looking at? So we help them articulate that a lot better, and we get inspirations because we do a lot of secondary research globally, so we are able to get a lot of inspirations from some new interesting thoughts and ideas that people have done in other countries, and or maybe some interesting ingredients. Like, for example, I talked about familiarity and taste and stuff. We have seen, like, let's say if I'm taking a very functional protein kind of a product, right, but I marry that with certain traditional well-known ingredients, right? So I'm saying turmeric and stuff like that is of course very commonly known, but let's say if I'm looking at millets, I'm looking at amaranth, I'm looking at some of those things which people say, yeah, I use, let's say, and I keep telling this to a lot of people, there is, in India, we have a very strong habit of having fasting grains and fasting foods, right? I have not seen anybody yet take that and say, hey, can I use some of that? And which is intuitively for me, which gives you because it's probably lower GI, gives you a longer duration of, not feeling hunger for longer and things like that. Can I use some of those ingredients which I intuitively understand? Hey, I know amaranth does this. I know, a kuttu ka atta does this, or a ragi does this, right? Can I be using some of those ingredients smartly into my product to differentiate versus my competition? So that is what we help our startups articulate and then come to a proper brief. Yeah. But I mean, yeah, but feel free to write into me offline, and, happy to help in any way I can. Yeah.
Yeah, that's great. I'll pass over your email definitely so they can reach out to you. The next question is from Satnam. He's asking if he's curious to know that if Thinking Folk also assists with the regulatory aspect.
Yes, we do. We have a separate regulatory team, and we do regulatory for India. We do it also for global. So we are able to do compliance. We are able to do common labels. So sometimes companies comes to us and say, I want to launch in India and Middle East and, let's say, US, for example. So we have to tell them, then this is what your label will, and I want to have one label or max 2 labels. So, this is what your label should look like. But yeah, for regulatory for India, yes, we do help them. And we don't do the physical thing of getting licenses, but we help them with all the documentation and everything that you need to get the license.
Great, thank you. So Karan's next question is from Karan. He's asking, when you outsource the manufacturing of a product, especially at an early stage, what are some of the factors that you do not have a control over, or what's the disadvantage?
So I think when you're looking at manufacturing, and especially if you're doing it outsourced manufacturing, like you said, what one is, of course, the volumes, right? So typically, if you go to a very large manufacturer who has all the process and systems in place and all of that, they would typically require pretty high minimum order quantities. But what we managed to be able to do in the last so many years now is to work with the smaller manufacturers with some of the minimum order quantities and so on, but give very clear output standards that you want. So if you, let's say I have an output specification, my product has to match that specification and so on, right? You will give certain inputs, where you may say, I have certain criteria, at least, that there is a certain process, what should I say, a process, repeatability, is what I would say. What you don't have a control over, to be honest with you, is, let's say, if it's an extremely small plant, rather I would say the other way around, and it, you see it and that this product is not going to come out safe, I would never approve that plant, right? I would say you much rather set up something of your own, really small, and do it and all of that, because food safety is super important. But if you are looking at saying, I'll do a minimum batch size of, let's say, 500 kgs or whatever, and even a mid-sized plant is okay with me. I'm okay to give up on some of their other things that they may have, some other compliances and whatever. Regulatory FSSAI compliance, they must have certain criteria, like a small analytical laboratory, et cetera, they must have, right? Which is able to give me consistent product. Yeah. And one thing that you have to check with them is, like, of course, let's say if they're doing competition products, and there are many factories who do that. What you don't have a control over, to be honest with you, is while you'll sign off a lot of agreements, how do you ensure that you've got your formulation completely protected. And one way that we do it with some of our clients is we black box certain parts of the formulation. So what we do is, let's say a formulation has 20 ingredients, right? You will create a black box of about 5 or 6 ingredients and get it manufactured at a plant A, right? Plant A supplies the black boxed ingredient, whatever premix, whatever you want to call it, to plant B. So plant B has no idea what plant A has, right? And that helps to, get some control over that, those kind of issues. Yeah, I don't know. I hope that answers your question.
Yeah. All right. I think the audience is really engaging. I think they have a lot of questions for you today. I think I'll take 2 more questions before we move. So Shreyansh from Terra Matter has a question about what would you suggest for all protein ingredient makers who are making single cell proteins for all dairy or plant-based meat products?
Sorry, just can you clarify the question again? Can you just come down a bit? I'm not able to see the whole question.
Oh, scroll through it. You can.
Yeah, I can see it now.
Yeah.
Okay. So we are, in fact, right now we're trying to work with somebody who's looking at a single cell kind of thing. Now, what we're doing is, what we would like to do is to be able to use some of those applications and put it into the generic product category applications it's going into. Let's say if I'm taking a certain particular type of protein or whatever, and I'm doing, precision fermentation and stuff like that, and I'm looking at which applications does it go in. So what we would typically do is we would first characterize. So that's what we did for algal, mycelial, all of that. We would characterize that particular single cell, sort of ingredient or active, whatever you want to call that. And how does it behave in, let's say, for example, a milkshake or an ice cream or whatever category it's going to go into. So we've done a lot of that. We've done that in breads and biscuits and whatnot. Now, once we've got that, and we know that, if I take this particular ingredient and I marry it with some other things which give it functionality and so on, you're able to go to a customer with a final solution, which is to say, hey, I've got a cookie. This is plant-based and so on. And this is the active ingredient that's going in, etc. And the final characteristics, which means maybe texture, maybe whatever, sensory and all of those things, are matching what a typical dairy-based, product would have. So you need to characterize, I would say, your, single cell kind of, protein that you're trying to take. Yeah. And what applications is it going in? Is it giving the similar characteristics which I would otherwise get from another protein source? Yeah. So that's how we go about it.
Great. Thank you. I think he has a follow-up question as well about which specific ingredient is the most sought after during end product formulations. What are the major gaps these end product companies are facing in terms of taste and texture parity?
This is actually a rather long question, and I would suggest, why don't you just write into me? And I know you guys are running out of time as well. But yeah, I mean, there is a lot that is happening in this space. And there are lots of different ingredients. Yeah. So like I said, mushroom is one big area. So there's a lot of mycelial proteins happening. We are seeing, of course, alternate to dairy. We always are seeing that for sure. And also, complementing ingredients are important. So let's say if I'm looking at fibers, certain starches, certain emulsifiers and things like that, certain usage of fats, certain seasonings, let's say, umami flavors, for example, we need to put in certain types of umami flavors, which are complementing, either they are amplifying or they are masking. That's what, you need to work with a lot of good flavor houses who are doing an enormous amount of work in this space. And I think that's how we work with some of these guys to find solutions. Yeah.
That's great. Thank you so much, Rinka. I know we have a couple of other questions, but I think this has been great. Thank you so much for taking out the time and coming on board. I think this was a great presentation. Even I think I learned so much just from listening to you speak. Thank you for making the time.
Thank you.
Yeah. All right. So we'll now move to Dr. Gurmeet. Dr. Gurmeet, you can turn on your camera as well. Yes. Thank you. Hello, sir. So we can get started. I think most of the participants will already know who you are. So no need for introductions. We can just directly jump into your presentation. And similar to the last format, everyone, you can keep dropping your questions throughout the presentation. We'll take it right after the presentation.
Okay, hi everyone. The topic given to me was texturization and extrusion methodologies for plant-based meats. So kind of jumping straight into it. Uh, I think the first thing that we need to know is when we're looking at extruded stuff, extruded proteins and texturized proteins is what kind. Firstly, the product coming out is actually an intermediate, right, which will eventually be for an application. And there are a number of applications, and we need to be really clear about what the application is, right? Is it a ready-to-eat snack, right, which is possible through extrusion? Is it to be blended with meat as an extender kind of an application? Is it a meat-like product on its own? Is it a restructured meat, which is it is minced and then pressed or formatted to look like a burger or a fillet or something or a nugget? Or is it a high moisture, high-end product which looks like a whole meat, right, coming out? Or is it like a canned pet food, retortable, which is a low-end meat product, right? So each one of these is a slightly different product, and it's a slightly different process, and it's a different ingredient set that you use. So this clarity is actually extremely important. So most of the times when people come to us, and I think in the space of texturized proteins, more than 30 companies and startups have kind of come to us for their trials. And there is a lot of confusion where they want to actually start off with, right? And why they want. I mean, many people come, hey, I want a high moisture meat analog. Why go for a high moisture when you can do it off a dry TVP, because that would solve a number of problems of cost of supply chain, etc., etc. So this part needs to be clear, and I'll just give some reasons, just to explain this point. So, for example, high protein snacks, right? Ready to eat snacks, texture needs to be crunchy, crispy, not hard, and you would do with the soy flour would do the job. But what we are extremely looking for most of the time, what we've seen is success is got by looking at low solubility protein powders. So this is very odd, because for most of the other applications, especially the very high-end applications for heat, we require very high solubility powders. But here it's the low solubility powders would work. Also, too high a protein content makes it very hard and not very crispy. And therefore, you need to dilute the protein content here. So which is why begin with isolates, or even concentrates. You could go down to flours here, right? When you come to chunk style TVPs, right? The original applications here were meat extender applications, right? And these were kind of products which in India were like the soy chunks that all of us are very familiar with growing up. The protein chunks, the very spongy chunks. So the texture quite random, quite spongy, very chewy, very light, right? So they're not dense at all, right? And most of them are made from soy flour concentrates. And what you're looking for is very high level of expansion here, right? That's so very high expansion dyes which are used here. If you're looking at the next application, which kind of started becoming popular was after the soy chunks, was the structured meat analogs, right? And the fibrous vegetable proteins. The difference between the structured meat analogs and the previous application, right, of the chunks is largely the density, right? If you start getting the earlier application to being a little more dense, then you start looking at these products rather than become soy chunks and Nutella chunks. They can start beginning to look a little bit like meat on their own, dry meat products. And this is where the Wenger process actually became extremely popular world over. They used twin screw extruders rather than single screw extruders with expansion dies, which is what the first two products were largely about. And that's how they got more density. But it did require long drying times, right? And therefore, there were a lot of Maillard reactions and hardness which would creep. And so they're not really ideal. And but they're lower cost, right, products. And then you have the fibrous vegetarian proteins. This is the dry TVPs that many of us are very familiar with. They are dry TVP, but they do have strands in them, fibrous strands in them, and they require therefore very high solubility proteins in there, and typically soy isolates, combination with wheat gluten, and you require high viscosity starches in there as well, right? So that's the kind of mix that's required for the dry TVPs from a meat application, and you require twin screw extruders with expansion dies, but you also require ideally a bowl chopper. Will give you very nice draw out of fibers, coming out of it. So if you pair the two, you really get to start getting to the right mix here, right? High moisture meat analogs, a lot of people are familiar with. These are high-end consumer products, can be both minced structured applications, but the real winner here is, of course, the whole meats which are possible. This requires a high L by D twin screw extruder, typically L by D of 40, which is the length to diameter ratio of the extruder. So very long extruders compared to their diameters, and they require equally long cooling die, right, which cools the product down very quickly below 100 degrees centigrade before it actually comes out. And then you have the low moisture meat analogs, which a few people are trying, not much success, which is trying to see if a twin screw extruder without a cooling die can also give you some fibrous structures, some success, but of course not as good as HMMA. So it's good to look at when we, now many of you may not actually be extruding materials, but buying ingredients. So it's good to ask what kind of a process, or at least be able to hack through when you look at the various TVPs and HMAs that you get, that once you have a good idea of how these products are made, what ingredients are used, you could do some simple hydration studies, simple protein analysis, and figure out what kind of process must have been done. And therefore, when you go and buy materials from someone else, because the first thing you have to do is look at who would your supplier be and what kind of ingredients. It's nice to be able to hack through and figure out what product you're getting sold, right? And that helps you then figure out what space do you want to be in, right? So of course, there are two main processes when you look at the various kind of extrudates which are available, the 6-7 that I mentioned. The two main approaches for texturization. One is the low moisture and one is the high moisture. And I'll just quickly go through these two methods. So the low moisture rely on expansion for texturization. The high moisture are very dense, they are non-expanded. Moisture of low moisture is less than 25%, whereas the other one is typically greater than 50%, right? And up to about 75%. From spongy fibrous low moisture products to fibrous and dense high moisture products, you have the big advantage of the low moisture, of course, is ambient stability, right? If you're buying a load of them, you don't need a refrigerator to store this. They are very low density products, very bulky products. So refrigeration would become extremely costly. So you want the moisture to be fairly low, and these are ambient stable. That's the big advantage. Whereas you require at least a chilling, if not a frozen, for a high moisture, right? And there's a lot of raw material flexibility when it comes to low moisture, wide range of flours, concentrate, isolates, which can be mixed and matched to what you require. Wide range of plant protein sources can also be used because expansion is way, way easier. Almost every protein will expand reasonably, and you could add starches and other things to it for expansion. But when it comes to texturization for high moisture, then soy is by far the best, followed by pea, and very few others which texturize well enough, right, for a premium product. The applications, as I said, high moisture has the advantage of really good whole meat analogs, where the others are largely into the mince space. And the low moisture ones, of course, require hydration before you use them. They'll pick up for every 1 kg of dry product, you'll pick up at least about 3 kgs of water before you start using it. Whereas high moisture ones, you really don't require hydration, maybe only a mild, because they're already at 60-70%, but you may require some marination, right? So dry TVP, the process would become, you have your protein powder, you make your blend prep, you take it to an extruder company, and there are a few in India now, at least one HMMA one and a few low moisture ones. Once they extrude out, then they will size it for you depending on what kind of a material you're looking for, chunk or strips or wet cut material. Eventually it'll be dried down to a moisture level of below 7%, around 3 to 7%, so that's stable. That's the dry TVP that you get. You can buy that directly as well if you're not looking for a proprietary blend. And then you do rehydration when you want to use it. And it's an ingredient now ready to use, just like meat is. And you could create minced products like patties, burgers, kebabs, nuggets, sausages, etc. from it. The ingredient I mentioned, that dry TVP, is very flexible in terms of what it can use. So soy, pea, wheat, chickpea, fava bean, and you can think of others, rice, protein, etc. as well in there. And you can blend it with cereal flours, fibers, starches, minor ingredients to improve some characteristics. In fact, quite high amounts can be used of flours, etc. And a wide range of protein concentrations. You could use protein-rich flours like defatted soy flour, or a protein-shifted legume concentrate, which would be about 50 to 60% protein, or wet concentrates, which are typically 60 to 80%, and isolates, which are above 80%. So you could, any of these could be used depending on what you're looking for, right? But extremely important to look at the quality part. As I said, one of the key things when you're looking at texture is the protein solubility, right? The protein dispersibility index, as it's called. If you're looking at a nutrient value, of course, besides the amino acid profile, you are also looking at how racemized your proteins is, because only the L amino acids are useful and not the D ones for the human. So those are a few things that get changed during the handling of the proteins, or the extraction of the proteins, or even the beans and the dals before that. So for example, soya beans are typically toasted, right? And depending on the toast level before anything else is done to them, right, gives you a different solubility. So the low protein dispersibility are the high ones are better extruded products, so you're looking for good solubility, right? Then the quality impacts a lot of different things, right? It impacts what kind of shapes you can get for your proteins. It impacts how much of water and oil they will hold in the final product, right? So the juiciness, they'll impact the chewiness of the rehydrated proteins. They'll impact the extrusion process and the blend flexibility, right? If you are going to be blending, if you're an extruder company, or you're going to give your material to the extruder, how tight your parameters are going to be, how many batches may fail, right? All that you require both the extrusion process flexibility and the blend flexibility there. And then, of course, the capacity of a production line also depends on the protein quality. So it's extremely important that we understand things like solubility, the fat content in the powder density and granularity, the flow characteristics of the powder, because all of them have an impact, right? This is a interesting comparison. These are two products. They are both burger patties, which are sold in India, or at least one was sold in India. Now it's off the market, right? And what you can see is both burger patties, but if you look at the protein levels, right? On the left, in the black, you see protein level is about 7.6 grams per 100 gram. And here you have about 17.4 grams per 100 gram, right? So, and if you look at the amount of water that each of these two patties have, you could add, for example, here 17.4 plus 10 for carbohydrates and fat, 10 grams, and you'll end up with about, say, 70, 65, so about 65, 70% water in this product and 17% protein, right? Whereas here, as I said, 7.6% grams of protein. But if you start adding things up, 7 protein, 25 carbohydrate, and 13 fat, so that's nearly 50%. So this product on the black side is only 50% moisture, and of the 50% solids, only 7 grams is protein, whereas on the other hand, the other one is 65% moisture, So this one will be a fairly dry product because this is supposed to be reheated, right? So already at 50% moisture, it will be a very dry, hard product. It has only 7 grams of protein per 100 grams. The other one is a lot more water holding capacity in there and will be more juicier, also very high level of protein. So, and the reason you would end up probably are the protein sources they went to, right? And this is just one example. When someone comes to us, we do ask them the question, where do they want to end up with, right? In terms of what kind of moisture in the end product, because that will control overall the number of calories, right? That they can deliver. What kind of protein levels do they want to? So a standard product, for example, the one on the left, which had only about 7 grams of protein per 100 grams, we could use a dry defatted soy flour almost as 100% ingredient for a dry TVP product because it has only 50% protein, right? So it will end up with a low protein content in the burger patty. But if you wanted to improve the protein content in the patty, you may want to go to a soy concentrate to start off with or a soy isolate. So you can make a standard extrudate here, what we call as a superior level, and then a premium level extrudate, right, in there. And then if you want a chicken kind of a character, then we want to start mixing in wheat gluten or some other ingredients as well, and get to them. So you start mixing the isolates with the gluten, but even concentrates with gluten will do here. And then if somebody doesn't want a soy character, then probably a pea protein concentrate could be brought in instead of soy, but a little different characteristic, as I said, the lesser fibration in there, and so on and so forth. So I hope you get an idea as to that you have to start thinking backwards in terms of what do you want in your end product, how much of calories, how much of protein, and then go back and what kind of protein coming from soy and pea, of course, but also then if you start getting into the next level of complexity, which is what kind of amino acid profile, where you need to start then mixing proteins, different things together. But if you have to begin there, do your spreadsheet calculations very clearly, and then start going back into what kind of ingredients you want to select, right? So just a few slides on what the dry TVP and the low moisture TVP extrusion and the high moisture extrusion process are all about. Well, there are two main steps in a low moisture process. We have the extruder, which is called the screw section. This is where the thermomechanical cooking happens. Basically, you're putting your protein powder in here, some water, and you're creating a very uniform, homogeneous melt, right? Many people want to buy low-cost extruders. Low-cost extruders have a challenge of not very good feeders, and therefore you have inconsistencies of mixing and not very homogeneous melts. Also, the temperature profile is not very well maintained across the, so you require really good controls and heating mechanisms and cooling mechanisms in your screw section to be able to deliver quality ingredients. The texturization actually happens in this small die here, right, in the dry TVP, where it's basically a expansion die, and there is some shear happening, there is rapid expansion, and the expansion is actually quite high. The pressure here just before the die may be 100 bar, and just coming out will be like ambient. So it's almost like 100 bar pressure drop, temperature about 150 or so, and the water just flashes off, right? The water which is held because of 100 bar pressure as liquid becomes a vapor as soon as it comes out, and that causes the expansion. And you're hoping that your network, the protein melt, you've created enough aggregation in there so that as water becomes vapor, the network stretches and manages to hold on, is stiff enough to hold on and doesn't just collapse right back like sometimes a souffle would, right? You also require various shapes, right? Depending on what you're doing. So you may require chunks, you may require slices, strips, granules, etc. And that's where the importance of the die design and the cutter design come in, right? And I'll just show very quick examples. There are a lot of different kinds of dies which are available, and each one of them, and then the die inserts what kind of shapes that you're looking for. And they have a huge impact on the kind of shape, and the shape will have an impact on what kind of products that you can make. Similarly, not much focus is given to the cutters, but cutters are extremely important And these are two main categories of cutters are called face ribbed cutters and face cut cutters. Basically, what you see in the picture here is a face cut cutter, because you can see the knife is flush against the die, right? And it actually just cuts the extruded as the die exit with blood flush to the die. Will give you larger chunks, granules. The face ribbed ones, there is a gap between the blades. They're not in contact with the die. This is the kind of die, actually the cutter that we have is a face ribbed one in our pilot plant. And then of course you may require wet milling as well, especially if you're doing a face cut, which is that the material coming out is then sent to a cutter, a secondary cutter later on, something like an Urshel cutter. Urshel Combitrol is a very common one which is used in industry, a very reliable one. And then after the extruder, you do require a dryer, because as I mentioned, the material coming out will be somewhere between 15 and 25%. So you will have to go through a secondary dryer. Could be a tray dryer, a belt dryer, a fluid bed dryer. 15 to 20% moisture coming out of the extruder. So that's the feed to the dryer, and eventually less than 10%, right, going out. And usually operated at a temperature 100 to 110 degrees, because you don't want too much of Maillard reactions and Strecker degradation reactions, because then you start getting colors on the exterior, not on the interior. So you'll have a mix, not very uniform materials coming out if you grind them and use it for minced applications, right? And finally, then you have your dry TVP, which needs to be productized. And so you have hydration, mincing, creating an emulsion, blending it with the emulsion, and then forming it into whatever shape you want, a burger patty or sausage, etc., and then cooking it and getting your final product. So those are various other unit operations that are typically required in the plant. High moisture meat analogs process is a little different. The key requirements are you require high protein powders. Here you can't do good texturization with just flours. You do require concentrates. Usually you don't require an isolate, because isolates will give you very hard texture product, but concentrates in the range of about 70-80% protein do give you very good texturized products. You need to get rid of all the other ingredients to a level so that the protein starts seeing each other enough and create textures. And then in terms of moisture, you require a high moisture, as I mentioned, 60, above 60% typically. 65 to 70 give the best textures usually. And then you require, in terms of equipment, you require a long L by D, right? The diameter, the length of the extruder needs to be very long compared to the diameter, typically 40 times the diameter, at least, right? And well-controlled heating zones I had mentioned, and long cooling dies as well. So the L by D or the cooling die is also very, very long. As you can see in the diagram here, this is the extruder, the cooling die is pretty much as long as the extruder, right? Same here. This is all the cooling die here, right? The extruder is in the back. The importance of screw elements cannot be overemphasized, and their arrangement. So you have a number of screws. The advantage of a twin screw extruder versus a single screw extruder is that you can arrange it in infinite ways, but you need to know how to arrange them. And because if you don't arrange the screw elements in the right way, you may end up with disastrous, right? Extrudates coming out, not good textures coming out. So there's a certain experience that counts, at how do you arrange your conveying blocks and reverse mixing blocks and kneading blocks and rupture blocks. How many of each do you require? At what stage do you require? And for different proteins, different textures, you need to keep changing these to get the right mix. The cooling die, as I said, needs to be long. One reason this long cooling die is that it fills up, it makes sure that your extruder part is filled up with protein, and that's what creates a dense product. So dense character is a very differentiating character of the proteins compared to the low moisture ones, which are expanded and bulky, right? The temperatures are way lower here, 130 degrees. The pressure is way lower, only about between 5 and 10 bar as opposed to 100 bar there, right? And you're aiming for good network formation, gelling characteristic, and then shaping it. Today, the whole thing about shaping, where the industry is evolving, is that you're able to get thicker and thicker slices. So 20 meter, I've seen now 40 slices, 60 slices coming. So that's now really getting into chunky fillet, whole meat, fillet cut kind of applications, right? The productization here is you cut your extruded coming out, you marinate it, you shape and form, You coat it if it is required, and then you cook it, right? Largely. So this is for a whole meat. The minced is pretty much similar to the earlier one. Finally, whatever the case be, you need to look at texture. One aspect, certainly taste is a big one as well. Color is another one. But I'll just speak on texture, that you're looking at not just a single parameter match, but a full spectrum match, right? Hardness, cohesiveness, springiness, resilience, and you have texture analyzers to do that. And something called a 2-bite test is a very industry standard and gives us good results as well. We find that very useful. And it basically simulates how much of force that your jaw is using versus time in 2 bites, a first bite and a second bite. And then the area under the curve, the peak height, etc., allows you to calculate some of these measures or translate some of these sensory measures into instrumental measures, good estimates. So this is an example of close to 50 different extrudates, and you can see that just by changing parameters and some blends, we are able to change the hardness to chewiness profile of each of these. So depending on what the product is, a huge amount of flexibility which can be created with shami kebab kind of textures, galoti kebab kind of things coming here, to more harder textures, whole meat kind of here, and the shami and seekh kebab somewhere in between, right? So you can create a lot of different things. This is just showing the full spectrum matches, that this is what a chicken breast texture is like, this is what a beef texture is like, this is what the green is a lamb texture, and then these are various runs and how each of them are, while they seem to be matching on hardness and chewiness, we could get matches, but on the resilience and cohesiveness and springiness, we have too strong a resilient. The plant-based meat here, it doesn't seem to be breaking that easily. It's too cohesive, doesn't seem to come apart too easily. It's too springy, too spongy, right? So then you have to start changing the blend, getting in different proteins, and so that you can bring these elements down in this space. Yeah. This is just an example of we used millets with proteins, and being able to get a variety of different textures, and going all the way from chicken to mutton kind of textures, very different fiber lengths, very different thicknesses of the fiber, depending on incorporation level, etc. So you have a lot of flexibility, which can be brought about by raw material selection, by equipment configuration, especially the screw element design, the screw configuration. The L by D you can't change of the equipment. Once you have an equipment, that's it, right? But dies, cutters, screw configurations is what you can change. And of course, process parameters, the feed rate, the RBM, the barrel temp, the die temperatures, etc. And what you're trying to manipulate these to get, your desired cohesiveness, springiness, resilience, etc. But in between, of course, are a lot of other parameters that we need to understand. At least the researchers and the product developers, the technology guys on the team, extrusion team, will need to understand to be able to get things right. Yeah. And so that's what takes you from designer ingredients to winning products. And then once your prototypes at a pilot scale are ready to go to scale up, right? If you have the right scale up parameters. Cool. So I'll stop here.
Thank you, Dr. Gurmeet. I think that was super insightful and very detailed. It really would have helped all our participants understand the process in the space so much better. There are a couple of questions in the Q&A box. I'll just quickly take them. The first one is, what are the additives used to obtain the meat-like texture in extruded plant-based products?
So what are the additives, right? I mean, the texture part actually really just comes from a combination of various proteins. You could use starches, as I said. If you are getting too dense products, you may want, or you have a protein which does not hold enough water, so you may want to put in the water to hold a starch to hold water. You could have a little bit of oil there, a couple of percent, 2 to 5% oil may help in some cases. But the other things, of course, come during the next stage, which is you will require some colorant, some flavorants, etc. But you wouldn't put them during the extrusion stage. You will do that during the formulation stage, right? Because you don't want to waste or degrade any of them during the high pressure, high temperature exposure during the extrusion stage. But your additives are the standard E numbers, the binders, the emulsifiers, the flavorants, the antioxidants, any fortificants that you require, right? And they should all come at the later stage. The texture, you will mostly we are able to get good texture with just protein blends, maybe some starch addition or pectin addition. Yeah.
Thank you. Yeah, I think that should have answered the question. The second question is, what would be the digestibility of high moisture extruded plant-based meat?
What would be the digestibility? I mean, digestibility all depends on. So firstly, if you are eating a protein as a dal, for example, right, that you would cook at home, right? So any plant protein taken in its native form versus in its extruded form, right? The extruded form will have probably about 10 to 15% better digestibility, right? So I keep saying that one way to solve the protein shortage is if you extruded all your proteins, plant proteins, the protein requirement of the world goes down by 15%, right? Because they're 15% more digestible in some sense. So digestibility of extruded products is higher, right? Whether low moisture or high moisture product. Cool?
Yeah, that's great. Thank you. The next question is, why hasn't the plant-based sector achieved whole cut meat products? What are the challenges?
It is more challenging, definitely. I mean, because but it is happening, right? And it requires, as I said, the high moisture meat analogs, right? For which, if you look at the equipment required, very few players in the world have those kind of equipments as of today, right? So that becomes the first hurdle. If you look at India pilot plant, I think that we have probably the only maybe one more pilot plant now at a scale which has the high moisture meat analog capability. And of course, B-Veg has at an industrial scale. And there are two others which are getting set up at the industrial scale to make high moisture meat analogs. So that's number one, right? That you have limited. The other is, of course, the textural challenge is way greater than in a minced product. It is less forgiving than in a minced product, which creates challenges, right? And the challenge of creating a thickness which is like a meat, right? So you require, as I said, 10 mm, 20 mm, 30 mm kind of thicknesses, right? To get a whole meat slab and boneless slab, and then the texture has to be pretty much uniform throughout. So that's a tough challenge, not easily achieved, right? So I think there are still gaps there. While they are acceptable products, we still need great products coming out through that approach. So people are resorting to whole meat, looking like mimicking whole meat by taking the minced products and pressing them in layers to get to whole meat kind of appearances. So those are the two plays right now. So both of them a little less than ideal, while they can serve a base purpose. Yeah.
Got it. Yeah, I think that should have answered the question. The last question is, how do different extrusion conditions influence the color development and Maillard reactions in plant-based meat products? And how is this managed to achieve desirable sensory characteristics?
So yeah, the higher the temperature, the more the Maillard reaction, right? So which is why if you're making dry TVP kind of products, largely you would be more, less in the white chicken territory, right? It's difficult to achieve a white chicken territory because most expanded products are extruded at 150 degrees centigrade, right? Low moisture condition. So you start getting a lot of color in there, right? Whereas if you're looking at the high moisture, then you have, with soy, you can go as low as 130. With pea, you do require to get to about 150 degrees centigrade. So for a chicken kind of a texture, soy and wheat blends do an excellent job, right? 120, 130, low Maillard development, low pressure. So all you're looking for is nice, clean powders, right? Which you are, when there are enough of them around, and you get a good chicken kind of a color, right? Otherwise, you start getting darker color. If you're happy with the brown meat concept, and many people are today. In fact, many people are looking for brown meat, then a higher 130 degree, 140 degrees is also fine. Yeah. So you can play around with temperature. And again, as I said, looking at the ingredients, looking at what you begin with the end product profile that you want to aim for, right? What is your differentiator on multiple levels, right, for your end product, and then start backtracking to what you're looking for from the ingredient space. Cool.
That was, I think, definitely helpful. Thank you so much, Dr. Gurmeet, for hosting this masterclass for all our ISPIC participants. I'm sure that it would have been really helpful in terms of now that they're taking the next step in the phase 2. I think this would have been super useful. It's been great for me and Siddharth as well, just to hear from you as well. Thank you so much for coming in. Yeah, I think that's it for all the questions.
Thank you.
We can sign off there. Thank you everyone else for attending as well.
Thank you. Bye-bye.